What's up, Chem peeps? Let's take a look at another problem involving excess and limiting reactants and bust out an ice table to help us answer it, which describes the final laboratory observations when 0.40 moles of sodium hydroxide is added to 0.50 liters of 0.60 molar copper 2 chloride solution. I can't wait to solve this one. First, with all types of stoichiometry problems, we need to have a balanced chemical equation. So I'm going to do that first. Boom. Okay, so the first part of this question is really getting you to think about solubility rules. Do you know how to use the solubility rules to figure out whether or not you formed a precipitate? Now, for AP chemistry, you have to know that any group 1 metal compounds will always be soluble, including nitrate or ammonium. But you have to lock that knowledge away. So notice here that my sodium chloride contains sodium, a group 1 metal, so that's totally going to be soluble or aqueous, right? Now, you don't have to know the other rules from memory, but if you check out a solubility chart, or if it's provided, you would find that this, in fact, does form a solid precipitate. It's insoluble. So that narrows this thing down to either answer choice A or answer choice B. We are going to form a precipitate. Next, let's set up an ice table to solve the other part of this problem. Boom, beautiful ice table. I'm going to plug in my 0.40 moles of sodium hydroxide, and then I'm going to take a quick timeout to use the molarity equation for my amount of copper 2 chloride in moles. I've got a 0.60 molar solution, and I've got 0.50 liters of it. I'm going to slip it into scientific notation because it helps me when I'm doing math without a calculator. 6 times 5 is 30, and then I'm going to add my exponents here times 10 to the minus 2. I'm going to bump that over 1 to put it into correct notation, which is going to be 3.0 times 10 to the minus 1, which is the same as 0.30 moles for my copper 2 chloride. Awesome. I'm going to throw that into my ice table. Boom. Initially, I don't have any of my products. As I think about determining which of these is the limiting reactant, I'm going to take my number of moles and I'm going to divide each of them by their respective coefficient. So 0.30 divided by 1 is 0.3, 0.40 divided by 2 is 0.2, and that gives me 0.2, which is smaller, making this my limiting reactant. Now, I'm going to just finish this ice table for you. You may not need to at this point, but I'm going to do it just so you can see how ice tables work. If this is my limiting reactant, it's going to get completely used up, so decrease by 0.40. This is going to decrease by half, or 0.20 moles, again, using the ratio in the balanced chemical equation. This is going to increase by 0.40, and this is going to increase by 0.20. So at the end, 0, 0.10, 0.40, and 0.20, meaning that not only do you get a precipitate that forms, but the thing that's going to be excess, copper 2 chloride, which means I'll have some extra copper ions floating around. Boom.